This is 5.1b, polynomials with negative exponents. Very similar to the last section. We just have some negative exponents involved. Okay, so we want to simplify polynomials using the power, product, and quotient rules with negative exponents. Okay, so our rules are going to be the same, right? We have product of powers, quotient of powers, negative exponent, power, power, power product, power quotient, and the zero power. Okay, so these are all the same. You can see examples here, keeping in mind that the product of powers and the power of a power are often confused. Just so you know, you don't need to know these names. You just need to be able to use them. Okay, x squared times x cubed is x to the fifth. We add those exponents. X squared to the third power is x to the sixth. So this is when we multiply the exponents. Okay, with negative exponents, which is what this section mainly focuses on. We're going to use this rule a lot, where we send it to the opposite side of the fraction bar. Okay, so something like this, pretty straightforward. X to the negative fifth times x squared. You kind of have a choice here. We could multiply like this, right? So when we multiply two terms with the same base, we add their exponents. So negative 5 plus 2 would give us x to the negative third. But I never want you to leave your answer with a negative exponent. I want you to rewrite it as 1 over x cubed. Okay. Or if you want, if you prefer, another method is to rewrite it first. Rewrite it as 1 over x to the fifth times x squared. And then this is going to turn into x squared over x to the fifth. And then you can use your quotient rule, right? 5 minus 2 is 3, and it's going to stay on the side with the bigger exponent, 1 over x cubed. Either way, you get the same thing. All right, let's look at something like this. Okay, so we start off with a negative exponent in the numerator. What we're going to do is send that to the opposite side of the fraction bar. Okay, so I like to draw my fraction bar first. This x squared is going to stay in the denominator, and this x to the negative third is going to come down, and when it comes down, it becomes positive 3. What's on top? Just 1. Okay, one more step to simplify. We want to try to clear up this denominator a little bit. X squared times x cubed. When we have two exponents with the same base, we are going to add their exponents when we multiply. Okay, so this is going to become 1 over x to the fifth. Okay, another way to think about it, if you want, using that quotient of powers rule, right? 2 minus negative 3, so we're still subtracting. 2 minus negative 3, x to the 2 minus negative 3 is really like 2 plus 3, so you still end up with 1 over x to the fifth. Okay, I like to think about it this way a little bit better. It's just the way my brain likes it, but both ways work. Next example, let's see if we can combine some of these. So you have a choice, right? You can cube everything first and then deal with your negative exponent, or you can deal with your negative exponent first, then cube everything. Doesn't really matter which one, so I'm going to cube everything first. Negative 2 raised to the third power is negative 8. X squared cubed gives us x to the sixth. Y to the negative fourth cubed. Multiply those, you get y to the negative 12th. And then clean it up. Negative 8x to the sixth. That y to the negative 12th is going to go on the opposite side of the fraction bar. And then when it does, its exponent becomes positive. Negative 8x to the sixth, y to the 12th. That is all we can do. And looks like we are missing any. Oh, there it is. There's your example. All right, this one is the most complicated. All right. This is my suggestion. Okay, put a star by this. Put a star by this and circle the negative exponent, and then just say flip first. Okay, we're going to flip it first, and that's going to take care of this negative. Okay, so this denominator, 3x to the negative second, y squared z to the negative seventh, that's going to become our numerator. Before we do anything else, that's what we're going to do. 3x to the negative second, y squared z to the negative seventh over this 15. So now your numerator goes to the denominator, 15x to the fifth. All the exponents, signs are going to stay the same right now. Okay, in this step. And then now all of this, instead of being to the negative second power, now it's to the positive second power. So the act of flipping first takes care of the negative. Takes care of the negative. And then now we just go on like we would, okay? I'm going to clean this up inside first before I square it. So draw my big fraction bar. 3 and 15 are both divisible by 3, so I'd be left with 1 on top and 5 on the bottom. X to the negative second and x to the fifth. So 5 minus negative 2 would give me x to the 7th in the denominator. Y squared and y to the negative third, it's going to stay on the side with the bigger number, which is 2. Okay, so y squared, so 2 minus negative 3 would give us y to the 5th. And then z to the negative 7th and z squared, this z to the negative 7th is going to move to the opposite side. And when it does, it'll come down here and become z to the 9th. Okay, and remember, we're not quite done yet. This is still all being squared. And so we just got to raise everything to the second power. I'm going to leave off this 1 now because 1 squared is just 1. Okay, y to the 5th squared gives us y to the 10th. 5 squared gives us 25 in our denominator. X to the 7th squared, power to a power, multiply them, you'll get x to the 14th. Z to the 9th squared will give us power to a power, multiply 9 times 2 to give us z to the 18th. And there you go. That is one of the most involved examples you will see, right? This negative exponent out here means we have to flip the numerator and the denominator first. That's the easiest way to go about this kind of problem. Take a look at your practice. Let me know what questions you have.